I want to tell you something that took me 15 years in the industry to fully understand. The best engineers I've worked with, the ones who've actually moved things, they just don't know their domain. They also understand systems, how things connect, how something you built today affects some decisions which you will take 6 months from today. Hi, I'm Avinash, Head of Academics at Polaris. I spent the last 15 years in the industry and even co-founded a fintech startup. One question kept coming back to me, and that was not about the work, but about the people doing the work. Why do so many engineers arrive at their first jobs knowing so much, but being able to do so little? That question is why I'm here today. There's a design flaw at the heart of most engineering education in India. And it's not the faculty, it's not the students. It's the assumption the whole system is built on, that you learn first and then you apply. That is not how real world learning applies. 4 years of theory, then industry. That is not how learning actually works. You don't learn to swim by studying water. You get into it. At Polaris, we threw out that assumption entirely. Our curriculum is built on one principle. Understanding comes from doing, not the other way around. You learn by doing on day one, not year 3, not after placements, but on day 1, you write code. You build things, you push things out to real repositories. That is what makes the curriculum different. Let me be specific about what makes the academic design at Polaris different. Because industry first is something every college says. But at Polaris, first means specialization right from day 0. On day 1 itself, you choose between applied AI, product management, or cloud and big data. And then everything, your entire curriculum, your entire projects, your mentors, your internships are intentionally designed around that specialization. That focus is intentional, because I don't think the world needs more generalist graduates. It needs people who can go deep. Second, a living syllabus. There is one thing which I'm very proud of as the head of academics at Polaris. Most curricula are static. A committee decides what needs to be taught in 2018 and students are still learning it in 2028. At Polaris, the curriculum evolves with the industry. What's happening in the real world right now is in the classroom right now. When Gen AI became the dominant paradigm, we didn't wait for a decade to review the curriculum. We updated it on the go. That is just our philosophy. That is how we operate. And you don't just learn about what Gen AI is. You build on top of LLM models. You deploy your products. You deploy your projects. You watch things being used. You watch things being failed. You figure out why. And that is the cycle we care about, of you learning by doing. I think about pedagogy a lot, probably more than most people want to hear about. The traditional model is professors teach, students absorb, exams test recall. That model was designed for a world which was before Google, before OpenAI, where information was scarce. You needed somebody to transmit knowledge to you. That world doesn't exist anymore. Information is everywhere. Knowledge is everywhere. What students need now is the ability to critically think, ability to make judgments, and ability to problem solve. So at Polaris, every year of the program has a certain theme going on which enables you to do this. The first year is the seed, the foundations, programming, data structures, maths, databases, the things that enable you to do first principles thinking, thinkings which don't go out of date. Year 2 is grow. You start building complex systems. You start applying these concepts which you have learned. Full stack development, data science, some Gen AI projects. Year 3 is disruption. This is where things get serious. How do you use LLMs? What is ML ops? What is AI infrastructure? How do you build production systems? The things which companies desperately are looking for when they are looking to hire somebody. Year 4 is launch. You are embedded in the industry. A company, a research lab, or your own startup. Go build something meaningful which real world users are actually using. But here's what the framework doesn't tell you. In year 2, our students are already building startups. They're building startups in the YC summer school. They're building Gen AI applications. They're building real products. In year 3, they're building on top of LLMs like RAG-powered chatbots, fine-tuning models, AI agents with tool calls. By the time they graduate, they would have logged in more than 5,000 hours of actual coding, not simulated, not assignments, but real systems. And many of them which are actually deployed in production and running. That's an apprenticeship. That is how you learn by doing. It is not just a plain syllabus of learn from textbooks. The people teaching here and mentoring here are real world practitioners. People who have built real systems at real scale. We have a network of industry mentors from Google, Amazon, Visa, and other companies who teach specific modules, specific workflows. When a mentor tells you this architecture will not work in production, this architecture will not scale, and they problem solve the reasons with you, they know that because they have seen it happen. The lessons land very differently. It is not just theory, it's their memory becoming your instinct. We also have students contributing to open source from their first year. And that is the only way you can bring in 1 million lines of code and thousands of developers into academia, by giving our students the ability to contribute to open source. Google Summer of Code, Linux Foundation, Summer of Bitcoin, these are all built into the program. 11 students from our first batch made it to GSOC, 9 of them first years. And that's not luck, that is very intentional. That is what happens when you stop treating learning as preparation for real work and just start doing the real work. Just start giving back. I joined Polaris because I believe the model we are building here is the right one. Not the easiest, not the most familiar, but from first principles, the right one. If you are a student considering this, I'll tell you what I tell every student I speak to. Don't ask, is this college safe? Ask, will this college make me uncomfortable enough to grow? And that is where true growth happens. Because comfort is the enemy of learning. And the engineers who change things, the ones who build, the ones whose systems are being used, they were uncomfortable from the early days. And they were uncomfortable very often. That is what we are here to do. Come build something you can be proud of.